Hello. Going to go ahead. I know it's kind of dark, but the recorder will show up. Now it's brightening up. I want to answer a couple of questions that were about the homework. One was about how to get a regression line from data given in a problem. And the second one dealt with residuals. And the third one dealt with how do you get a plotted regression line so you can check your answers. So without further ado, let's go to share screen and let's take a look. Now this first question here was a sampling homework question. Now, by the way, Krugman is a very famous economist. He writes in the New York Times and he also won a Nobel Prize or the equivalent for economics. And he is also a professor. So, and what this deals with is he wants to predict a final exam. He says he lost a final exam and he has a regression line. And what he does is he says, okay, there's a pre-exam score and he has a formula that says if you made a certain score in a pre-exam, you can predict what your final exam is. So the explanatory variable, the X variable, will be the pre-exam scores. Your response variable, your Y variable, will be the final exam scores. And if you read this, it says the pre-exam have a mean of 280, standard deviation of 40. The final exams have a mean of 75 and a standard deviation of 8. And when he did the regression, he found R was equal to 0.5. So going onto the whiteboard, and let's go to our ladybug. I have this written down, okay? And here's the thing. He's using the pre-test to predict the final. So the pre-test is the X, the final exam is the Y. And all I did was write the stuff down on the whiteboard. R is 0.5. The pre-exam or mean is 280, that's X bar. Your standard deviation is 40, that's given in the problem. This is Y bar, and this is S of Y. So let's first write down what the regression line is. And we can do that. I'll go ahead and take a picture of this. We can do this. And the first thing you know is you had a formula in the text that told you if your Y hat, your predicted Y's, were equal to A plus MX, remember the X's will be the input, the pre-exam scores. You need to figure out the slope in the A. The first thing you do is remember that the slope is given by the regression coefficient times Sy over Sx. In our case, by the data, it was 0.5. Your Sx is 40, your Sy is 8. Like so. Okay. Just a quick check to make sure. I'm pretty, 99.9% sure it's right, but having a brain freeze, and let's see. Well, I'm actually looking to tell you where you can look this up anytime you like, and you can look that up anytime you like on page. It's on page 132. I wanted to get this reference for you. So it's page 132. But this is correct right here, Sy over Xx. And the way to remember that is that your standard deviation of your Y is what you're trying to get a Y from an X. So if you do a little bit of dimensional analysis, you can think of this X canceling an X in this denominator. That's not quite right, but it helps you see that. So 0.5 times 8 is 4 divided by 40, and it's equal to 0.1. So your slope is equal to 0.1. I've got the book out to show you. It can tell you where the formula is. So m is 0.1, okay? Now the next thing we need to do is we need to figure out what this a is. Well, the way to figure out the a is if you input y bar for y hat and x bar for x hat, you get y bar minus mx hat. It will be your a. Well, the y bar is 75. The slope was 0.1 that we just calculated, and the x bar is 280. And we get 75 minus 0.1 times 280, and we get 47. Okay, so that is the slope. So the regression line the predicted y, and that's what the hat means, it's a prediction, is 47 plus 0.1 times x. Okay, now we said, he said Julie made a 300, so at x equal 300, the answer is y is hat is equal to 47 plus 0.1 times 300, which is 77. So that's what the prediction is for that problem. So to recap, the steps are identify what x bar is. That's the mean of the explanatory variable. Identify what s of x is. That's the standard deviation of the explanatory variable. Identify y bar, the mean of the response variable. Identify 8, which is the standard deviation of the response variable. And to see what's being asked for, you want to predict what that is. To predict what that is, you find the slope as we did here. And again, I'll just write the slope formula is here. The formula for the y-intercept is here. And then you input all of this and you're done. So that's how you do that problem. The next question dealt with this. So I'm going to go to one of the things right here. And you had this question. And what I'm going to do with this question is I'm going to show you what a residual is and how to do this. And what I'm going to do, let's see, I don't really have that. Let's see. Yeah, I actually have the data right here, so I don't have to work too much to input this, but let's do it. Let's go to Crunch It. And let's go ahead, and I'll go ahead and just enter, I'll just enter this thing right here. And I do have the numbers that I'm entering word from the chart. Now you could probably, okay, you could probably do this by uploading the appropriate data set. In fact, let's go ahead and look for the data set rather than try to do this. It's from chapter 5, the data set that we're talking about here. It's an airline one. So let's just go ahead and look at this. Chapter 5. Because that sure looks, and it'll save us from entering all the data, although you could. Because I still sure looks familiar. And let's see here. And let's see here. The, you know, come to think of it, where this is actually from chapter 4, I think. Yes, it is. Yes, it is. It's 4-point data set 4.5. It's exercise 4.5 is the data set. So we go to chapter 4 and look at 4.5. No, that's not the right one. Bear with me here, chapter 4. Exercise 5. Yeah, that's it. That's it. That's a correct thing. So now I don't have to enter all this in. So sorry about that, but yeah, that's the data. I know I've seen it before. Now, the very first thing you want to do is you want to figure out what a regression line looks like. And let's go over how to get what the line is. And that way we can talk about what the residuals are. I didn't really discuss residuals in class too much, but let's go ahead and do this. Let's go to statistics. Let's go to regression, simple linear. And let's first of all look at the dependent variable. And the dependent variable is going to be the response variable, so that's going to be delay. The independent variable, that's going to be the explanatory variable, that's going to be outsource. And let's calculate. And what we find right here is an equation, and that's going to be important for answering a question here. And I'll write it down on the whiteboard. Y bar is equal to 25.11 minus 0.1449 times outsource, where X is outsource. Okay, so let's go ahead and look at the ladybug. And there you go. That is read straight from the Crunch It output. Okay, that's what it reads right there. Now, if you want to see what the graph looks like, let's do the regression again. But this time, instead of numerical results, let's look at the fitted plot. And we see right there, this blue line is the regression line. And that's what the regression line plot looks like. So I'll take a screenshot of that and save it. Paint. And just move this up, move this out like this. And I'll copy that and I'll say airline plot. Now, the last question will have to do with residuals. So I think we could actually figure out what the residuals are. First of all, let's look at what Crunch shows, but then I'll go ahead and explain by hand. In fact, let me explain by hand what a residual is. So let's get out of the way here. And so let's say you want to figure out the residuals for let's say x equal 51. And then let's say for x equal 46.3. And let's say x equal 52.6. Now these columns right here are the xi's. So when you go here, this front column, that's the first xi. The 51.0 is the first, that's x1, that's x2, that's x3, that's x4, and so forth. So let me write that down for you in red. So let's see here. X of 1 is 51.0. Your y sub 1 is your actual. And then your x sub 2, and let's just right here. And I'm not going to do this for every one, but 29.4. Your y sub 2 is 20.32, etc. So now let's calculate the residuals. And for the residuals, I'm going to use a 51, 46.3, and 52.6. So let's do that. Now, you can set up the computer to do this quickly, but I want to show you by hand. And I just went ahead and I need to, first of all, write down the actual y's. The actual y's for each one of these. This is struggling a little bit, so let's just see this one works. The actual y that goes with this is, for 51, the actual y is 10.35. For 46.3, your actual y is 21.42. And for 52.6, the actual is 23.46. So a residual is the difference between the predicted and the actual. Now, Crunchit will calculate the residuals for you, but I want to show you by hand. So let's go up to this ladybug here so you can see this. So the residuals are for 51. These are the actual table values right here. This is what you read off the table. This is your actual data. They're paired together, like so. So to figure out what the residuals are, you see the difference between the actual and this formula here. So let's go ahead and do that. Remember, so let's do the first residual, and I think it'll be clear here. For 51, the formula predicts (25.11 minus 0.1449 times 51. The actual formula is 25.11 minus 0.1449 times 51. And the actual is, so that's 17.72. And this is going to be your yi hat. In this case, your y, let's call that 1. But anyway, that's your y hat. That's a predicted. Now, I want to just check briefly which, it's going to be the difference, but I want to be close to the textbook here. So which one goes first? Okay, it's observed minus predicted. Okay. Now the observed, that's the table value. That's a 10.35. So the residual is 10.35 minus 17.72. So 10.35 minus 17.72, it's minus 7.37. Now let's do this one here, 46.3. The formula predicts 25.11 minus 0.1449 times your input. So it's going to be 25.11 minus 0.1449 times 46.3. So your y hat predicted is 18.40, and the observed, that's taken from the table value, that's 21.42. So the difference is, remember, it's going to be the observed minus the predicted. That will be your residual. Then we get 3.0 rounding to 3.02. So what you remember here is this is a takeaway, the residual will be, in this case, always remember this, 10.35 is going to be the observed minus predicted. Okay? So that is that's a takeaway what this is. Now let's just see what Crunchit does with those. Let's do another regression. Same thing, simple linear. Delay outsort. Let's look at the residuals. And the residuals are in fact the observed minus the predicted. Now, we said for our 51, we found out that our residual is minus 7.37. Well, you can see minus, this is 0, this is minus 5, that's about minus 7.37. We also looked at x as 46.3, that's here. We said our residual is 3.02, and sure enough, there it is. So that is how you actually calculate a residual there. I mean, that's how you actually plot the residuals. So the residuals are how far off the regression line the observed data is. Okay, so it's always, remember, the observed minus the predicted. So I hope that helps there.